Okay, so this video is going to go through the formative test on logs that was recently on D2L or Google Classroom, and the questions might be in a slightly different order than what you did them, but they are all of the questions that are there. So given f of x is 3 ln x, excuse me, so remember ln, oops, better make that a pen. Ln is a base e log. So 3 ln x is the same as 3 log base e of x. And since e is greater than 1, we're looking at a log that has this shape. Goes from Q4 to Q1, intercepts at 1. So our x's are not reals. They are greater than 0, and our y's are reals. And so our answer is B, or B. I guess also on this last one, you could have just graphed 3 ln x. So let's just go in here and just say y equals, and go 3 ln x, and hit graph, and seeing that shape of the ln graph. The graph of y equals 4 log x. All right, so 3 ln x and, or sorry, 4 log 6. That should be like 4 log 6x or something, because 4 log 6 is just a number. So that was bad on mine, but it's going to start in quadrant 4 and go to quadrant 1. So the answer will be 4, 1. Little typo. I'll check over your answers, make sure nobody was affected by that. The statement that is true for all 4 log x. Okay, so remember 4 log x, like the other questions, looks like this. So the domain is all real numbers. Not true. There's a vertical asymptote. That's a line a curve approaches but does not touch. The x-intercept is 1. There is no y-intercept. There is no horizontal asymptote. And the range is all real numbers. Okay, so those 3 characteristics are true for 4 log x. The x-intercept of y equals 1/2 log base b of x, where b is greater than 0 and b is not equal to 1, is. So what do we get for an x-intercept? Well, the x-intercept means that y is equal to 0. So 0 is equal to 1/2 log base b of x. So we can multiply both sides by 2, which will give us 0 is equal to log base b of x. And then to solve for x, we take b to the 0, so x is equal to b to the 0, so x is equal to 1. So our x-intercept is 1. Actually, that's true of any log graph, right? The x-intercept is always equal to 1. The value of log base 3 108 divided by 4 plus log base 3 of 243. So if we take 108 divided by 4, 108 divided by 4 is 27, then this is log base 3 27 plus log base 3 1 over 243. Well, 27 is 3 cubed, or another way, it's just 3 to the 3 is 27, but you can do log base 3 of 3 cubed. 243 is 3 to the 5th. So the log base 3 of 3 cubed is just the 3. Let's turn this into 3 to the negative fifth. So 3 plus negative 5 is negative 2. So there's your answer. Now you could also have done this on your calculator, right? So you can do a base 3 log. So I would do the log of this divided by the log of 3, and then the log of this divided by the log of 3. So what's that going to look like? Log, so 108 divided by 4 divided by log 3. So that will be my first one. I could just hit enter here, right? We'll just get that 3. So that evaluates to 3. And then log 1 divided by 243, excuse me, divided by log 3. So that's using the base change formula. And that gives us minus 5. So 3 plus negative 5. And that's our negative 2. Excuse me. Next up, when converted to exponential form. Okay, so remember, this is y is equal to log base e of x. In exponential form, this is the base. A log is an exponent, so that's the exponent, and that's the value. So e to the y equals x, which is a, or a. The simplified form of 3 log base 2a plus log base 2 of b squared. So we want to put these all together using the laws of logs. We can't do that with a number out front. So the 3 out front simply becomes a power plus log base 2. Now this is already a power, so we're good with that, b squared, minus log base 2c, and again, same deal, we can't have that. So plus means multiply, and minus means divide. So this is log base 2. So a cubed, b squared, multiply, divide by c to the 1/2. Now c to the 1/2 is square root of c, so an exponent of 1/2. And so we have log base 2, don't forget the base. So there's nothing out front. And there's no 6 inside or anything like that. So our answer is C. 2, log base 5, 15, blah, blah, blah. So now it's log base 5, so really what we're doing is simplifying this expression. So kind of really the exact same thing, right? This will be log base 5 of 15 squared minus log base 5 of 10 plus log base 5 of 4 squared, right? So these guys get moved up, become powers. And now we can use, so if it's adding, they're up top. So it's log base 5. So up top, 15 squared. Also the 4 squared, okay, so times 4 squared over 10. Now this is just using your formula sheet. So this will be log base 5 of 225 times 16 over 10. And let's get a calculator to do that. So 225 times 16, enter, divided by 10 is 360. So it's log base 5 of 360. So our answer is 360. Moving right along. The expression that is not equivalent to. So we can convert this to any base. So to convert to base 3, it becomes the log. Now remember, this is a base 10. It becomes the log base 3 of the value over the log base 3 of the base. So that's perfectly fine. 81 can be written as 9 squared. So this is the log of 9 squared, which becomes 2 log 9. 81 is 3 to the power of 4. But 3 log 27 would be the log of 27 cubed, which is not 81. So that is the one that is not equivalent. If you have any questions about any of these, don't hesitate to email. Log base 4 of 24, so this one is very similar to one we did before. So it's going to be log base 4. So 24 times 12, so when you're adding, minus over 2, which is basically going to be 12 times 12, or 144. The expression that is equivalent to, okay, so just straight off the formula sheet, it's log x minus log y. Okay, the log of a quotient is equal to the difference of the individual logs. The expression that is not equivalent to, so another one of these. Well, it's not that, because it should be log x over log 100, right? If we change to a different base, then log 5, so the log of whatever our new base is of the value over the log of whatever our new base is of the number. And what's this doing? Well, it's saying we could change this to log base 10. So log base 10 of x over log base 10 of 100. Now, we don't write the base, so if the base isn't written, it is a base 10 log. And log base 10 of 100, 10 to the what gives you 100, and the answer is 2. So this is also equivalent, and this is the odd one out. Value of x that solves this expression. Okay, so, I mean, really you could do this on your calculator as an exponential, right? But what we'll do, so the first step is isolate anything, right, that's there. So 12 divided by 5 is 2.4. Let me pull up the calculator. Let's just clear this. So 12 divided by 5. So 2.4 is equal to 2 to the x minus 4. Now we could log both sides and do all of that, or we can just rewrite this as a log. So our base is 2. The value we're going to end up with is 2.4. And the exponent is x minus 4. So x will be 4 plus, add 4 to both sides, log base 2, 2.4. So if I go alpha f2, I can get to log base number 5. So log base 2 of 2.4. Enter, and then add 4 to that, so plus 4. And we get 5.26, rounded to the nearest hundredth. Okay, what if you can't do that? Then you do the log of 2.4, so log 2.4. So if you have an older calculator, you have to use the base change divided by log 2. And you'll get your 1.26. So it's alpha f2 number 5 gives you log base. Okay, and if you don't have that version of the calculator, then you just do it as the log of the value divided by the log of the base. Okay, let's clear that if we need the calculator again. Student correctly expressed the answer to 4 to the x plus 3 equals 25 in the form x equals, so in log form. So if we take this, right, we're just going to convert it to a log. So log, well, our base is 4. The value we get is 25. And that's going to be equal to the exponent, x plus 3. So x will be log base 4 of 25 minus 3. And you can see we're in this form now, right? Log base, so the base is 4, and we've got 25. And then the minus 3, because we're subtracting 3 from both sides. So the value of a plus b, these two guys, is 29. Your answer is 29. The solution to, let me drag this down a bit so we can see the whole thing. So if I want to solve for x, well, we're going to do the same deal, right? So log base 5 of c is equal to 2x. So x will be log base 5 of c divided by 2. And here we are here. So not log base c of 5, right? Nowhere is the c a base. So I mean, you could look at this and just say, hey, nowhere is the c a base. And then this would be using base change formula to change to a base 10 log, but we don't need to do that, okay, because we already have our answer right here. If our answer was some kind of a base change formula, so if we looked at this and changed this to a base 10 log, let's just take log base 5 of c as a base 10 log, it would be log c over log 5. Which means this one might also be right. Because if it's a half of that, so that's not a good thing. Looks like we might have two possible correct answers. So I'll look through. Again, because it was formative, the marks aren't going to count anyways, but we'll make sure we do a better job in the future. If $200 is invested at 8% per annum, compounded semi-annually, the number of years it will take for the investment to at least double in value. Alright, so we are using this formula, which we've used a lot of times. So if I want to double, then I'm going to end up with $400. And we have to adjust the interest rate. So it's 0.08. So semi-annually is twice a year. Now, if I leave this as n, because that's what we're trying to solve for, then what I will get is the number. So in this particular case, n is the number of semi-annual periods. Semi-annual periods. Which means that I'm going to have to divide n by 2 to find out how many years. Okay, so to solve this, let's divide both sides. So 2 is equal to 1.04 to the n. So log base 1.04 of 2 is equal to n. So I want to do a log, so I'll do this using base change formula. Log 2 divided by log 1.04. And that's n, which is 17.67. So that's how many half years. So if we divide by 2, we'll get how many years. So n is 17.67 semi-annual periods, or half years. So the number of years is 8.84, so 9 years. Put this away. So 9 years. A log regression. Okay, so we've got the x's and the y. So best thing to do, second mem 4, clear all lists. So if you had anything in a list, this will just clear it all out. We go to Stat, Edit, and I'm going to need to see one more set of numbers. So 1, 2, 3, 4, 5, 6. So be careful. Sometimes it isn't 1, 2, 3, 4, 5, 6. Maybe they're missing the 4. They have 1, 2, 3, 5, 7 or something. So just make sure you're entering the numbers correctly. 2, 4.5. I mean, if we're doing this in front of the class, then, you know, we can all check and see. And if a lot of us get the same answer, we know it's correct. But in this case, on a test or a quiz, you're on your own. And 63.7. Now, anytime you're doing a test, you'll be told what type of regression. So stat calc, this is ln. Ln reg is number 9, so number 9. If you're just looking at ln reg, you're going to put a y1. Well, we don't really need to here. We're not actually graphing this, so we just want the value of b. But normally, so vars over to y vars, enter, enter. Normally, we put stuff into y1. Say calculate, value of b rounded to the nearest tenth would be 27.9. Okay, so we're not asked to find something like if this pattern continued, what would the value of y be in year 10 or something like that. Right, we could also do that. That would mean getting into the graphing window and setting our window and doing stuff with it. Okay, mathozope is a radioactive substance that has a half-life of 3.14 days. The science lab started with 500 grams. How many days? Well, it's kind of like this. That's our formula, right? So the amount that we end up with is the amount we start with, 1/2 to the t over 3.14. So that's the half-life. So first step, you can't do anything until you've divided both sides. So 900 divided by 500 is 1/2 to the t over 3.14. So 90, let's clear that. So 9d divided by 500, I don't have a 9. Okay, 90 divided by 500 is 0.018. 0.018 is 1/2 to the t over 3.14. So log, our base is 1/2. The value we end up with is 0.018, and that will be equal to t over 3.14. So t will be 3.14 times log base 1/2, 0.018. Okay, so I can go 3.14 times, this time, so you have to know how your calculator is going to handle this, log. So 1/2, I'm just going to put 0.5. And here, I'm just going to go 90 divided by 500. Okay, let it do that. And we get 7.768, so 8 days. And that's it. So I hope this is useful to you. The video and I'll put a PDF of all of the answers up on Schoology, which if you're looking at this, you know that's what happened.